All right, in this video, we're going to talk about estimating rates of change from a table. So this says the table shows the estimated percentage P of the population of Europe that uses cell phones. And the mid-year estimates are what we're seeing. Okay, so it says find the average rate of cell phone growth from 2000 to 2002. So an average in this context is going to be a slope of a secant line. So an average rate of change will be the change in percentage over that time interval divided by the change in time. So the answer to this question will be 77 minus 55 percentage points divided by 2002 minus 2000. Okay, so that's a difference of 22 divided by 2. So it's 11. And again, that's percent per year, right? Again, the units, just to remind you, the units on this is percentage, the units here are years, so there we get that rate. Okay, that's an average rate of cell growth of 11% per year between 2000 and 2002. Between 2000 and 2001, it would be this rate of change, so it's 68 minus 55 divided by 2001 minus 2000. And in this case, that's a difference of 13% per 1 year, so 13% per year. Okay, again, these are averages. 1999 to 2000, one more example. So again, we find the slope of the secant line there. It's a change of 55 minus 39 percentage points divided by a change in time. And so that is 16 divided by 1, so 16% per year. So those are all average rates of change. The last question here asks us to estimate the instantaneous rate of growth in 1998. So notice we don't have any data about 1998, and we don't even have a function that models this behavior, this relationship between percentage cell phone use and time. The best you can do in that case is to find the average rate of change of the time around it. So 1998 is in between these 2 years we don't have data for. If we find the average rate of change between those 2 years, that's really the best we can do in this situation. And to see why, just imagine this is essentially the model for our cell phone growth. We want this time, this is 1998, but we don't have it. We just have 1997 and 1999. Again, what we want is the slope of this tangent line if we're asked for an instantaneous rate of change. Right? We want this. Right? We want that. We can't get that directly. The best you can do is find the average rate of change of the points around it, and hopefully, in most cases, that's around parallel to the slope of the tangent line. But in any case, it's the best we can do. So we find the average rate of change using the points surrounding it. So we do 39 minus 28. So I'm going to say this is about equal to 39 minus 28 divided by 1999 minus 1997. Okay, and that's 39 minus 28 is 11% divided by 2 years. So we get 5.5% per year. That is our estimate for the instantaneous rate of growth in 1998. So let's turn to a different context just to kind of round this out in a different way. A little bit of interpretation as well. This says let T of T be the temperature in degrees Fahrenheit in Dallas, T hours after midnight on June 2nd, 2001. The table shows values of this function recorded every 2 hours. What is the meaning of T prime of 10? Estimate its value. So first, let's just describe the meaning of T prime of 10. So T prime of 10 is an instantaneous rate of change at time 10. This is the instantaneous rate of change of temperature in Dallas. Now T equals 10 would correspond to 10 a.m., right? Because this is supposed to be midnight. So 10 hours after that would be 10 a.m. So at 10 a.m. on June 2nd, 2001. And again, the best thing we can do to estimate that would be to use the points surrounding it. Now that's not the only thing we can do in this case, because in this case 10 is actually in the table. There are other ways to estimate the rate of change, using those 2 points or even using these 2 points. The problem is, in the long run, it just tends to be better to use the points surrounding it. And so we're just going to go with that for now. So T prime of 10, we're going to say is about equal to 88 minus 72 divided by 12 minus 8. Okay, so 88 minus 72 is 16 divided by 4. Again, the units on, just to help us express our answer, this is degrees Fahrenheit divided by hours. So we end up with 16 divided by 4, so it's 4 degrees Fahrenheit per hour. Okay, that's an estimated instantaneous rate of change of the temperature, instantaneous increase of the temperature at 10 a.m. in Dallas on this date.